Hey everyone, in this video I want to talk to you about programming in R. Now programming may sound like a bit of an intimidating word, but really at the heart of it, it's a pretty simple idea. The idea is that we want to repeat the same action over and over again across a set of different types of objects. Maybe different types of data sets, different type of vectors, different type of numbers. But at the heart of it, programming really means automating something that we can do by hand again and again and again. So let's try to learn a little bit about programming today through a kind of workable example. Let's go ahead and open up this senator's data.r data file that I provided to you in the notes for this video. Now if we open up this data set using our data browser, we'll see we've got a state, and then we've got the name of the senator. And if we come all the way over here, we see that we've got some kind of digital information about the senator: website name, contact page, Facebook URL, and Twitter URL. So let's say we wanted to do some kind of cool data collection. We wanted to collect all of the tweets, all of the 100 most recent tweets from all 50 senators in this database. Well, there's a really neat package in R called rtweet that you can install as follows. And rtweet is a package that allows us to talk to Twitter and download data. I discuss that process in more detail in one of my future videos. You can see here that I've installed the package. Now I'm going to load the package. Oops, forgot the R. And now I'm going to go ahead and try out the get timeline feature. So the get timeline feature, I happen to know from using this package a lot, allows me to put in the Twitter handle of any user and get back the most recent 100 tweets from that user. So let's take a look at our senators data set here. And I happened to notice earlier from looking at it that the name of the variable where the Twitter URL was located is called Twitter_URL. So if I want to just look at the first row of that, I can put this 1 in square brackets. That tells R I just want to look at the first element of that variable. And we see here a URL for Senator Dan Sullivan. So let's go ahead and try to put that URL into get timeline here. I'll create a new object called test, where we're going to hope that we get Senator Dan Sullivan's tweets. All right, unfortunately we got a warning message here. Sorry, that page does not exist. The problem I now realize is that we've passed the entire Twitter URL to the getTimeline function instead of just the Twitter handle or the ID of the user. If we wanted to figure out why that had happened, anytime you want to browse the help documentation of a function, you can write the question mark and then the name of the function and then open close parentheses. And we can look here in our help browser to see kind of what's going on. Here, if we scroll down here, we can see it requires a vector of username, so we could put in more than one, but here we're just putting in one, or user IDs. So a username here does not include all of this https://twitter.com. It just is this part right here, Senator Dan Sullivan. So one of the first things we need to do is to figure out how to trim our URL so that it just contains the user handle. Now there's a lot of different ways we could do this in R, but we're going to try out something called a function to automatically and pretty quickly change all of the URLs here into Twitter handles. So all that a function is a set of instructions. Think of it like a recipe that R can continue making something with. So to create a function, we need to give it a name. So I'll call mine Twitter URL remover. Then I simply write function, and that tells R that I want to write a function. And then every function requires an input. This is a little bit of a tricky point here. We have to think abstractly. We're going to want to put lots of different things into this function, lots of different URLs, not just one. So we have to give it an abstract identity. Here I'm going to call our abstract identity X, And if you're not following exactly what that means, don't worry. I think it'll become clearer as we work through an example here. Now, after we define what the inputs are to our function, then we have to kind of define what the function will do itself. Now, what we want to do here is trim off that little bit of the URL and have just the username. All right, so we know that what I need to do is extract the Twitter handle from the Twitter URL. But how do you do that? Well, let's imagine for a minute I didn't know how to do that. What would I do? Well, I would probably go ahead and start with a simple search. I would probably start by Googling something like replace string R. Now notice I used a little bit of jargon there. I wrote string. I knew that when people talk about programming problems, they often use the precise terminology to describe what they want to do. So technically what we want to do is replace a string. That URL, www.twitter.com, is actually a string. And what we want to learn to do is manipulate that string or replace it with something else. So I'll go ahead and Google that. A few different things come up here, but my eyes quickly go to stackoverflow.com. I'm going to go ahead and click there. And why do we like Stack Overflow? Well, Stack Overflow is a community of people who provide programming advice to each other. So in this case, we've got someone here who's asked a question. They would like to remove specific characters from strings within a vector. And you can see here to the left, there's these upvote buttons. And when a question is upvoted more, it creates a bounty, incentives for people to answer the question. And when they answer the question and their question gets upvoted, then the user gains reputational points on Stack Overflow, which translate into kind of career bona fides in the data science world. So here the poster has asked how to replace these E's within the data frame that she or he has created here. And you'll notice that the user has specified what their data frame looks like. They haven't just asked the question, how do I replace strings in R, right? And the reason they did that is because very often the answer depends on what your data looks like. And people trying to help you can't help you very well unless they see what you are going through. Now, the ideal solution might be to share your data, but sharing your data means maybe putting it publicly, and maybe you have some sensitive data you can't share, or maybe it's a big file and you can't host it easily. So very often people will try to create reproducible examples that other people can do on their machines in order to help you, using some kind of base data sets that ship as part of base R. Things like the cars data set, which describe different types of car qualities, or the iris data set, which describe different types of flowers, or the diamonds data set, which describe different kinds of diamonds. And then they'll kind of ask their question in terms of those data sets and then get a solution in terms of the data set. What the poster here has done is created a data frame, a pretty simple one with just 2 columns and 5 rows here, or 4 rows here, and then asked with this kind of toy example, how do I get rid of the E's? Now, as we scroll down here, we see there's 6 answers, but a really nice thing about Stack Overflow is that the most high quality answer, judged by the community of people, always rises to the top. So this answer received 407 upvotes, and this user is recommending using a function called gsub. And it says what gsub does here is to replace each occurrence of the character E with an empty string here. So we can see in this line of code, we could go ahead and copy and paste that into our code here and begin to figure out a way to transform this part of the URL that we're trying to get rid of into a blank space. So we're not trying to replace E, we are trying to replace this URL here, the beginning of the URL. And this is left over from the poster on Stack Overflow's data set. It was called group, or the variable is called group. And ours is actually called senators_data, Twitter URL. And let's just do the first one here to see if our gsub will work. And as I look down here in the console, we see that it did work. We extracted just the Twitter handle of Senator Dan Sullivan here. So now we're cooking. We've figured out a way to extract the Twitter handle that we need to pass to the getTimeline function. But now suppose we want to do this again and again and again. Well, here's where programming can become useful. Specifically, something called a function. We can write functions for lots of different things, but at its root, a function is a set of instructions which we can call upon whenever we want. So let's write a nice little function that helps us cut the Twitter URL off of a string here. I'll call it Twitter URL remover. And the way I write a function is I write function. You'll see it turned in a different color. It's indicating R is interpreting that as an instruction. And every function requires an input. Now this is a bit of a tricky concept. What an input here is going to be anything that we want to do a set of instructions on. So in this case, we might want to pass a lot of different, many of these different Twitter URLs to our function to extract the screen name or Twitter handle each time. So here I'm going to call that X, and I'll show you how that works in just a minute. Now, everything I put in between curly brackets in R is going to be the set of instructions that the function executes. So I can go ahead and take our G sub here, and what I want to do is obviously replace that URL with a blank space. But I don't want to do this just one time to this one part of the data frame. I want to do it to anything that I put into my function. And so instead of putting a single object here, I put this abstract variable X here. And now, anytime I put anything into the function, it will perform the gsub command on that thing, whatever it's called. So one kind of funky thing about functions is that it will perform whatever we tell it to do, but if we want to create a new object, we'll have to give it a new name. So I'll create a new object called handle here for Twitter handle. And then lastly, if I want to see it every time I run the function, I need to use this little function called return. And that's just saying, show me the thing I just created. Okay, so here's our function. You'll see it's now appearing in our environment pane over here under functions. And now that I've created this Twitter URL remover, I can begin to type it out here. You'll see I've got it in predictive text because it's now a known function within my environment. And let's go ahead and try that same URL that we began with. And let's see if we can pass it into our function here. Kind of put it in quotes. And extract just send Dan Sullivan, which is exactly what we were looking for. So this is a very simple example. We were just doing a simple character manipulation, restructuring a string here, or a character. But a function could do anything. A function could standardize a variable for a regression model, or a function could add on text instead of subtracting text, or a function could read in a bunch of files from a directory. Let's say you had a bunch of Word files that you wanted to read in to do some text analysis. So functions can do a lot of really useful stuff. But now imagine that we want to kind of do a few things, right? We don't just want to transform the URL into a screen name. We also want to, say, collect the 100 most recent tweets for all of the 50 senators in our data set. So we want to not only extract their Twitter handle, but then we also want to use that getTimeline function to get those tweets. In order to do this, we're going to have to introduce something called a loop. A loop is a kind of indispensable form of programming in many different programming languages. So in R, we very often use something called a for loop. A for loop simply takes an abstract value, not unlike the X we just created here, although often, kind of by convention, we use I instead of X. And what it says is take a value of I from a range between 1 and any other number. I'll start with just writing 1 to 5 here. And what that's going to do is, when I kind of put my set of instructions between these curly brackets here, as one does when you create a for loop, I is going to assume a different value between 1 and 5 each time I go through or iterate through the loop. So let's take a look at what that might look like. So first we want to get that handle. So we'll use our Twitter URL remover function that we created in the previous step. And here is the part of the data set that we extracted the first value for, right, just for Senator Dan Sullivan. But what we want to do is create the flexibility to iterate across the entire data frame to look at all the different names. So instead of writing 1 here, I'm going to write I here. And what that does is each time the loop goes through, I here assumes a value between 1 and 5. So the first time through the loop, it's going to extract the handle for Dan Sullivan. The second time through the loop, though, I will assume a value of 2, and then it will extract the handle for the second person, the second row of the data frame. Okay, so we can already do that, though, with our function. What we're trying to do here is put together some somewhat more complicated sets of instructions that we want to do again and again and again. So what we want to actually do is pass that handle into the getTimeline function. And this is what's actually going to give us the tweets. I'm creating a new object here called tweets. So now handle will assume a different value every time we go through the loop because I is going to change. And then we'll pass a different screen name to the get_timeline function each time and produce a new data set called tweets. Now we're getting pretty close. Each time we go through, we're creating a new data set. That's great. But if we create the new data set and don't store it anywhere, all that we're going to do is overwrite the data set again and again. And that's not what we want to do. We want to create a really big data set that combines the 100 most recent tweets for, in this case, the first 5 people in this data set. So what we need to do that is a little counterintuitive. We need to create a place to store that data before we start our loop. So what I'm going to do is create a blank data frame. I'll come up here and call it tweet holder. And to create a blank data frame, I'm going to use the as.dataframe function. And within the function, I could write 1, 2, 3, 4, 5. I could write words. I could write whatever to create a data frame. But I'm just going to create a blank one by writing null. That means a kind of a blank value within the data frame here. So now when I run that, you'll see I've created a new data frame over here, but it has 0 observations and 0 variables. And now what I'm going to do is take that blank variable, that blank data set, and append it or add on the tweets I just collected each time I go through the loop, making that tweet_holder data set bigger and bigger and bigger each time I go through the loop. The way I'm going to do that is to use another function called rbind. Rbind stands for row bind. It means bind 2 data sets together by rows. So I'm going to write tweet_holder, that's my blank data frame, rbind, and then I'm going to take that same blank data frame and bind it with the tweets data frame. Now the first time I go through my loop, because this is a blank data set, all I'm going to do is add the tweets for Senator Dan Sullivan to tweet holder here. But the second time I go through, tweet holder will already contain Dan Sullivan's tweets, and then I'll be adding on whoever's second in our data set, and they'll be added to the tweets as well. So let's go ahead and try to run our for loop here and see what happens. All right, I can tell R is working, that the for loop is running because of this stop sign here. Anytime I wanted to stop the for loop from running, I could hit that stop sign and it would stop. Now it's a pretty short for loop. It's only 5. There's only 5 iterations to do, so it finished up pretty quickly. And if I look over here, we did create a new data frame. It's called tweet holder, and here we can see we've got these tweets from Senator Dan Sullivan. And if we scroll all the way down, we'll see we're starting to get tweets from other senators here as well, Senator Doug Jones. But my kind of eyes are caught on one thing. We asked for 5 senators. We should have gotten 100 tweets from all 5 of them. So we should have 500 observations and not 400 observations here, 400 rows of data. Also in our console here, I noticed that there's this warning message. Sorry, that page does not exist. So the way I interpret this is that one of the 5 screen names that we tried to pass to our for loop here didn't work. Maybe it was spelled incorrectly or something like that. But which one was it? Well, with just 5, we could go through by hand and maybe open up Twitter and try to figure it out kind of one by one. But now imagine we have 10,000 Twitter names that we're trying to scrape. And then we'd really want to have some way of programmatically figuring out where our code broke. And what we're talking about now is a concept called debugging. Debugging means figuring out where your code breaks and then fixing it. Now, RStudio has a variety of really sophisticated and very useful tools for debugging your code. In fact, there's a whole menu up here for debugging your code. Those are a bit more advanced functions that you might get into as you progress into computational social science. For now, I'm going to teach you a kind of classic, very basic way to debug your code, which is simply to add a line at the end of your for loop and write something like print I. Now, the print function simply prints something out in the console. So if I write print hello, you'll see here in the console I've written hello. Now, by writing print I, I'm going to be able to monitor where that warning message came in the iterations that we're going through. So let's try running our loop again. 1, 2, 3, and it looks like the warning came as the for loop tried to execute the instructions we prepared on the fourth part of the data frame of this Twitter URL variable. So let's go ahead and instead of putting I here, I'm going to put in for, and that's going to look up the Twitter handle of that person. So let's go ahead and try to put this into Chrome and see what's happening here. Now I can see here it says this account doesn't exist, right? And so that's a pretty clear sign that something went wrong, that it was probably spelled wrong. It looks like maybe here that account was added at the end, and perhaps if I delete that account, sure enough, we get Richard Selby's page. So that was a way of debugging the code by using the print function to look at the iteration that created the problem. Another way to kind of debug your code is to give I a value. So I could give I a value like 2 here, and then I can simply run each line. So here I'm hitting Command Enter for each line and watching to see where it breaks, or kind of I could stop and in an intermediate fashion kind of inspect each of the objects that I create with each line of code. Now these are both really great practices no matter if you're a beginner or a really advanced programmer, and programming takes some time to get used to. A lot of these things are a little bit complicated, like the idea of an abstract value or an abstract variable. Why do I have to create a variable that can change values? Or why do I have to create a container to store my tweets? Or why might I want to debug my code? Now, if this is your very first time learning about programming, I expect that you're taking a lot in right now, and maybe you're not following every second of it. Maybe you don't feel like you could do every single instruction by yourself, but that's okay. A common misnomer is that one needs to learn to do everything from scratch in order to learn how to program. Now, it's great if you can learn to do stuff by scratch, but in an environment where so many people have written so much wonderful code, why not learn by example? Why not borrow someone else's code and try to work through it using your own data set? This is an excellent learning exercise that can help you figure out how to program more effectively. Now, I want to add in one last little bit of kind of bonus knowledge in this video. Suppose that we want to take the Twitter data that we just collected and merge it with the original data we started with. So let's say, for example, in this new Twitter data that we collected, there's a variable that describes the number of times each tweet is retweeted. And then suppose we had a hypothesis about how the age of the senator might be related to the number of retweets that the senator gets. Let's say we thought younger senators were more social media savvy and created more resonant social media messages, and we wanted to look at that in some kind of empirical analysis. Well, if we wanted to do that, we'd have to take our Twitter data set that we just generated in our for loop and then combine it or merge it with the data set that we began with, which is called senators_data. Now, data merging is really more of a data wrangling subject, and I covered that in an earlier video. But just to work through an example and to give you some real world kind of know-how, let's do a join, as it's called in R. So joins are part of the dplyr package, which is part of the tidyverse. So I'm just going to load the tidyverse here. And there's many different types of joins depending on how you want to do the merge. We're going to start with a very basic one. It's just called a left join. And the reason it's called a left join is it means take everything on the left object, or take the left object and merge it with the object on the right. So here we're merging two data frames. And in order to merge two data frames, there's one important assumption, and that is that the two data frames have a variable that has the same name. If they don't have the same name, then the merge can't be done. We'll get an error message. Now, in our senator's data frame, we have this Twitter URL, but it's not really a Twitter handle. Now, if I look at my tweet holder data set, we see that the Twitter handle is not even called Twitter handle, it's called screen name, which is a name that Twitter chose. So what I need to do is create a variable called screen name in our senators underscore data set that includes just the handle and not the full URL. If I include the URL, it won't merge because the URL is different than the screen name or Twitter handle. So what I'm going to do here is take our senators data, and I'm going to create a new variable called screen name. And I'm going to use that same gsub function we used earlier to replace the URL, the initial part of the URL here. Put it in quotes, comma, open and close quotes, and this means delete it, replace it with nothing. And then on the other side, I'm going to put senators data Twitter URL. And what this line of code is doing is creating a new variable called screen name that's just going to have the handle and not the whole URL. So let's go ahead and try that. Now if we browse this, I'm just going to highlight it and run it. We can see we've just got the screen names here. And we've just got the screen names here. Now, if we want to be careful, we should really go through and make sure that both are using the same capitalization convention. So is one side lowercase and the other side is uppercase, because Twitter is actually not case sensitive, and I happen to know in terms of these usernames. But for now, let's just assume they are. If they weren't, we could use the two upper or two lower functions to standardize the case of the text. But let's go ahead and try a left join. We see that it did the join, but we need to give it a name. Let's call it merged data. There it is. Now on the right-hand side of your screen, you can see we've got a single data set that combined our Twitter data with all of the data that we started out with, the data on the party of the senator, which we could then use to do some analysis to look at whether or not the senator's age impacted their retweet count. We can't quite see all of those variables that were added on because R only lets us browse about the first 100 columns of our data frame. Okay, so that's programming for you. Again, programming can get much, much more complicated, but a little goes a really long way. The next time you find yourself starting to do a repetitive task, challenge yourself to write a little function or a little for loop. It might be more difficult at first, but the more that you code and the more that this becomes like a muscle memory, the easier it will be next time, and the more that future you will thank you.